Okay, here's another dimensional analysis or factor label problem. Let's say that we know that there's 1 ton, or 1 ton is equal to 2,000 pounds. That's a conversion factor. That's an equivalency, right? If we know 2.2 pounds are in a kilo, that's called a conversion factor. All right, let's say you had a problem that says convert 2 tons to kilograms. Let's make it a little more. Let's say 2.3. 2.3 times to kilograms. That's the problem, okay? Sometimes you may be tempted to say, oh, I can do that in my head or whatever, but we don't want to do that because we know that eventually, or it's the procedure or the process that we're learning, going from one unit to another, and it's going to get more complicated. So we got to learn the simple process first, all right? Any of these problems, you always start by writing the number and the unit being given. All right, what's being given? All right, 2.3 tons. So every time we do a problem like this, we're going to start by writing down the given. 2.3 tons. All right? We don't want tons. What do we want ultimately? What unit? We're going from tons to what? Kilograms. So that's our final desired unit. Now, if you look here and you say, okay, what do I know about tons? All right, I know 1 ton is 2,000 pounds, and if I go from pounds, I could go from pounds to kilo, right? So you look at what's being, and I would always give you certain conversion factors to work with, all right? All right, so I don't want tons. In order to get rid of tons, I would put it on top or bottom. All right, if I put it on the top, it's going to be tons times tons, which is tons squared, and it would be a mess, right? So I'm going to put it on the bottom. All right, I know that 1 ton is equal to how many pounds? All right, 2,000, because that's given to us, right? Now I can cancel tons because they're identical units. I can cancel out tons to tons, top to bottom. Now I want to get rid of what unit? Pounds. Top or bottom of my next conversion? Bottom. Could I go from pounds directly to kilo? All right, yes, because I know 1 kilogram is equal to 2.2 pounds. All right. Now all I have to do, because I'm left with what the desired unit is, right? So now I just have to crunch the numbers, do the math. I'm going to multiply it all the way across, and I'm going to rewrite it for you. So I'm going to do 2.3 times 2,000 times 1 over, we know that's really over the number 1. Any number by itself is over the number 1. So 1 times 1 times 2.2. Take your calculator, and actually I'm gonna just do it all kind of a long way. Don't mess up by crunching the number incorrectly in your calculator. So go ahead and say 2.3 times 2,000 and write 4,600 over 1 times 2.2 is obviously 2.2 still. All right, now I'm going to divide 4,600 divided by 2.2. Now I get this really long number. I get 2090 decimal 909091. I'm going to tell you to take it at least to the 10th place, 1 place past the decimal. All right, so I'm going to do 2090.9 kilograms. All right, now I would stand back and say, okay, does that seem logical? Well, we know tons are really, really heavy, right? 2,000 pounds are in 1 ton, so I've got 2.3 tons. So I got a lot of pounds, over 4,000 pounds, right? Kilos are big, all right? 1 pound 1 kilo is 2.2 pounds. So I would expect that number to be pretty large, right? So if you get like a little baby number, tiny number, you know you did something wrong, right? But you know that sounds pretty logical. 2.3 tons, it's going to be, pretty heavy amount of kilos, right? Okay, so that again is another way we do, or another example of dimensional analysis, also called factor labor method. So to recap, what did we do? We wrote down the given first, and then we multiply by as many conversion factors as it takes in order to cancel all of our units that we don't want to have around, right? I've got to try to take tons all the way to kilo. And sometimes it may take multiple steps to get there. Just make sure you don't get sloppy. I'd encourage you to mark out all your identical units as you go. And then I like to circle my final unit to make sure that's all that's left, right? So, and there you have it, dimensional analysis.